This weird, lumpy, cauliflower-looking thing is sitting in a jar of milk. It looks like something that fell out of an alien spaceship. But here's the strange part. It's alive. And not just alive in some abstract scientific way. We're talking about something that grows, reproduces, and has been passed down through families for literally thousands of years. Some people even name them. Welcome to the secret life of KEFIR grains. And trust me, once you understand what's really happening inside these bizarre little organisms, you'll never look at fermentation the same way again. So what exactly are KEFIR grains? Because here's the first mind-bending fact. They're not grains at all. They're not a plant. They're not a fungus, exactly, and they're definitely not something you can grow from a seed or cultivate from a single organism. KEFIR grains are what scientists call a SCOBY, a symbiotic culture of bacteria and yeasts. But that dry definition doesn't even begin to capture what's actually happening here. Imagine a microscopic city where hundreds of different species of bacteria and yeast have formed an alliance so tight, so interdependent, that they literally build a structure together. They secrete a matrix of proteins and sugars called kefirin that acts like scaffolding, creating these lumpy gelatinous grains that we can hold in our hands. And here's where it gets truly bizarre. Nobody knows exactly where KEFIR grains came from. You can't make them from scratch. You can't synthesize them in a laboratory. The only way to get KEFIR grains is from someone who already has them. They've been passed down through generations, originating somewhere in the Caucasus Mountains thousands of years ago. And every single KEFIR grain on Earth today is a descendant of those original cultures. Just think about that for a second. The KEFIR grain sitting in someone's kitchen in California right now could be a direct descendant of grains that were fermenting milk in a shepherd's leather sack in the mountains of Georgia in the year 500 AD. Let's zoom in and see what's actually alive inside a KEFIR grain. Because when we say it's alive, we're talking about an entire ecosystem, a microscopic jungle with dozens of different species all working together. Now, inside a typical KEFIR grain, you'll find somewhere between 30 to 50 different strains of bacteria and yeast. So let's address the obvious question. What exactly are these microscopic residents doing in there? Well, quite a lot, as it happens. According to research, the grains should consist of approximately 80% lactobacilli, 12% yeasts, and 8% lactococci. Though, rather wonderfully, no two batches are ever quite the same. The lactobacilli are your workhorses, the backbone of the operation. These are rod-shaped bacteria, and they're doing what lactobacilli do best, chomping away at lactose, milk sugar, and converting it into lactic acid. We've also got leuconostoc bacteria producing compounds that give KEFIR its distinctive flavor. There are Streptococcus species, Acetobacter species that create acetic acid, and various yeasts, like Saccharomyces and Candida, that produce carbon dioxide and a tiny amount of alcohol. Now, here's something that should make you pause and consider the profound strangeness of what we've been discussing. The microbial composition of KEFIR grains can be considered extremely variable. Your KEFIR grains are not the same as mine. The grains in Moscow are different from the grains in Mumbai, which are different from the grains in Melbourne. Each set of grains is a unique ecosystem, shaped by its local environment, the particular milk it's been fed, the temperature of the room it's been kept in, even the hands that have touched it. They evolve in real time, adapting to their circumstances. They're living, breathing proof that terroir isn't just about wine. It applies to your fermented beverages too. But here's what makes this different from, say, yogurt. Yogurt uses just a handful of bacterial strains that work independently. KEFIR grains are a true symbiosis. These organisms aren't just coexisting, they're cooperating. They're sharing nutrients. They're creating compounds that feed each other. Some bacteria create the perfect environment for certain yeasts to thrive, and those yeasts produce compounds that help other bacteria flourish. It's like a microscopic economy where everyone has a job, and the whole system only works if everyone does their part. The bacteria feast on lactose and produce lactic acid, which lowers the pH and preserves the milk. The yeasts break down other compounds and produce CO2, which creates those characteristic bubbles. Other bacteria produce antimicrobial compounds that protect the entire colony from invaders. And the result of all this cooperation? The kefirin matrix, that rubbery structure that holds everything together. The organisms literally build their own house as they work. Now, here's where the alive part becomes impossible to ignore. Kefir grains grow, and they reproduce. Not in the way animals do, obviously, but in an undeniably biological way. Feed your kefir grains milk and they'll grow, sometimes slowly, sometimes doubling in size within a week. As they grow, pieces break off, creating new grains. These baby grains are genetically identical to the parent, essentially clones, but they're fully functional new organisms that can ferment milk on their own. People who keep kefir grains often find themselves with more than they know what to do with. They give them away to friends, they sell them online. Some people even eat the excess grains themselves because they're packed with probiotics. There are online communities dedicated to kefir grain sharing, where people mail their excess grains to strangers across the country, continuing this ancient tradition of passing along living cultures. And here's something that blows my mind. Kefir grains adapt. If you feed them cow's milk for long enough, they become optimized for cow's milk. Switch them to goat's milk, and over time they'll adapt to that new environment. The bacterial and yeast populations shift. Some species become more dominant, while others fade into the background. The grains are literally evolving in real time in your kitchen. Just like any living thing, kefir grains need to eat, and what they eat is lactose, the sugar in milk. Without food, they'll starve. Leave kefir grains without milk for too long and they'll start to deteriorate. The bacterial and yeast populations will crash. The structure will break down. But here's what's fascinating. Kefir grains can also hibernate. If you need to take a break from making kefir, you can rinse the grains, dry them out, and store them in the fridge or freezer. They'll go dormant, like seeds waiting for spring. The metabolic processes slow way down, but they don't die. Bring them back out, rehydrate them with milk, and within a few days or weeks, they'll wake up and start fermenting again. This is biological activity at its core. These organisms are responding to their environment, conserving energy when resources are scarce, and ramping up activity when food is plentiful. And the waste they produce? Well, that's what we drink. The kefir liquid is essentially the byproduct of all this bacterial and yeast activity. They consume lactose, proteins, and fats, and they excrete lactic acid, carbon dioxide, B vitamins, vitamin K, beneficial enzymes, and dozens of bioactive compounds. One organism's waste is our probiotic gold mine. Kefir grains aren't just passively sitting in milk. They're sensing and responding to their environment in sophisticated ways. Temperature matters enormously. At room temperature, the fermentation process is vigorous. The grains are active, the bacteria are reproducing rapidly, and you'll have kefir ready in 24 hours. Put those same grains in the fridge, and everything slows down dramatically. The fermentation doesn't stop entirely, but it might take a week or more to get the same result. The organisms are responding to temperature like any living thing would. The type of milk matters too. Full-fat milk versus skim milk produces different results because the grains are interacting with different available nutrients. Some bacteria preferentially break down fats, while others focus on proteins or sugars. Change the nutrient composition, and the microbial ecosystem shifts in response. Even the ratio of milk to grains changes the outcome. Use too little milk, and the grains will over-acidify their environment, essentially poisoning themselves with their own waste products. Use too much milk, and the fermentation will be weak and incomplete. The grains need the right balance, the right ecosystem conditions to thrive. This is active biological regulation. These aren't chemical reactions happening mechanically. This is life, responding and adapting to stay alive. And yes, kefir grains can die, which is maybe the most definitive proof that they're alive. Expose them to extreme heat and the proteins to denature, the bacteria and yeast cells to rupture, and the grain structure collapses. You'll be left with a slimy, dead mass that can't ferment anything. Starve them for too long, and the organisms will consume all available nutrients, then start dying off. The population crashes, the grain structure weakens and falls apart. Contaminate them with harmful bacteria or mold, and the whole ecosystem can collapse. The delicate balance is disrupted, the pathogenic organisms take over, and the kefir grain dies. People who keep kefir grains know this grief. They'll post in online forums, "I think I killed my grains. They're slimy and they smell wrong and they're not fermenting anymore." and the community will offer advice, often confirming the worst. Yes, those grains are indeed dead. You'll need to get new ones. This mortality, this vulnerability is a hallmark of life. KEFIR grains aren't eternal. They're not indestructible. They're living things that can thrive or perish based on how they're treated. So why does any of this matter? Why should we care whether KEFIR grains are alive or not? Well, because it changes how we think about fermentation, about food, and about our relationship with microorganisms. For most of human history, fermentation was treated as magic or alchemy. People didn't understand why milk turned into yogurt or why grape juice became wine. They just knew that if they did certain things, it happened. Now we understand it's life. It's biology. It's ecology happening at a microscopic scale. And KEFIR grains are one of the most complex, most sophisticated examples of this we have. They're a self-sustaining ecosystem that humans have kept alive for millennia, passing them from hand to hand, culture to culture. There's something deeply humbling about this. Every time someone feeds their KEFIR grains, they're participating in an ancient partnership between humans and microorganisms. They're caring for living things that their great-great-great-grandparents might have cared for. They're stewarding a form of life that predates modern civilization. We still don't fully understand them. Scientists have sequenced the genomes of many of the bacteria and yeasts in KEFIR grains. We don't know how the entire ecosystem organizes itself. We don't know why some strains dominate in some grains, while different strains dominate in others. We don't know exactly how the KEFIR matrix is constructed at the molecular level. We don't know if we could ever recreate KEFIR grains from scratch, even with all our modern biotechnology. These lumpy, weird, alien-looking things sitting in jars on kitchen counters around the world still hold secrets. So, the next time you see KEFIR grains, don't think of them as just a fermentation starter or a kitchen ingredient. Think of them as what they really are. Ancient, complex, living ecosystems. Microscopic cities where hundreds of species of bacteria and yeast work together in ways we're only beginning to understand. They grow, they reproduce, they eat, they respond to their environment. They can die. By any reasonable definition, KEFIR grains are alive. Not in some metaphorical sense, but genuinely, biologically alive. And that makes your morning probiotic drink a lot more interesting, doesn't it? If you found this fascinating, there's a whole world of fermentation and microorganisms out there waiting to blow your mind. Please give this video a thumbs up and consider subscribing to the channel. Believe it or not, 99% of our viewers haven't hit that subscribe button yet. It's totally free and just takes a second. We've got tons of cool stuff coming your way, and in the meantime, leave a comment down below. Share your thoughts with us. Your support helps us to keep exploring and uncovering the hidden side of what we eat. So, don't be shy. Hit that subscribe button and age like a fine cheese.